Namaste. मेरा नाम डॉक्टर रश्मि राणा and I'm from Sargangaram Hospital, New Delhi, India. So basically, we are working on brain tumor. So brain tumor एक दिमाग का बीमारी होती है जिसमें दिमाग में गांठ होती है. So हमने सोचा कि अपना प्रोटियोमिक्स जो ये कॉन्फ्रेंस भी APT एडवांस प्रोटियोमिक्स टेक्नोलॉजी as a proteomics person, why not we doing this as a early detection biomarker? So we find out there is one biomarker that is called galectin-3 binding protein, and that can detect brain tumor in plasma at early stage, and that we have been patented through our government of India, and we have published couple of articles in this. So now we are hoping we can detect brain tumor using plasma samples before any surgery or any clinical management of the brain tumor. And coming to this conference, I would like to thank Professor Sanjeeva Srivastava, who given me this opportunity to meeting eminent professor like Judith from Harvard, medical school. She's working on neuroscience, and other, eminent professor around the world. And Professor Sanjeeva always having a, moodomics, proteomics, and fun here, science plus cultural things, and we enjoyed. Thank you, Professor Sanjeeva and IIT. Thank you so much. Namaskar.
Then I think our entire, should I continue or should I continue? Yet I realized that there was huge interest among the students, among the participants, and lot of scientists and collaborators, clinicians, as well as the industry heavily supported this event. So of course, like, it was in my mind already a big hit because we have 16 countries, people participating in this event, scientists coming from almost 90 scientists from 16 countries, and several hundred and thousands of students and participants are here. So it was a good satisfaction and a big hit in a way that to begin with. But I feel very satisfied at how the response are coming now, and let's hope that this is going to be useful for many collaborations to come. Many of the scientists who are coming here, they will open up new projects, new opportunities for us in the future. So let's hope for the best from the APT for the future activities. Well, I'll be very happy, if our people are publishing to the same top journal what anybody from the top US lab publishes, right? The aim is to really train people, empower people. We are doing the workshop for that purpose. So I'll be very happy to see that, we are having equilibrium after a few years in that way. No, thank you so much for the discussion about it and all of your support. Thank you. Thank you.
So my name is Dr. Sanjeeva, and I'm a professor at the University of Manitoba, Winnipeg, Canada. I'm the director of Canada Italy Tissue Engineering Program and associate head Department of Physiology and Pathophysiology. So I'm running a research lab that focuses on cardiac stem cell therapy and tissue engineering. We use different types of stem cells and biomaterials to regenerate injured heart after a heart attack. So that's about it.
So what is this stem cell? What does it deal with? I mean, what is it all about? Can you only that जो audience समझ सके, in your own little words, how do you explain it?
So a stem cell is a cell in the body that can turn into any cell type within our body, so a mature cell. So stem cells are present in different organs within the body. They help in endogenous repair process. What I mean is, after any injury inside the body itself heals it.
You're coming all the way from your hometown to Mumbai in IIT Bombay. Just in your own little words.
Perfect, can do. So my name's Steve Pennington. Came to Bombay today to attend this Omics conference. I work in Dublin. I'm British by background, and I've always had a passion for proteomics and proteins. Former president of the Human Proteome Organization.
Okay. So what is this event all about? In your own little words, can you make us explain Omics and the technology that we are going to see today? We'll be speaking on about.
Yeah, so I think Omics is a really interesting name, and I haven't heard it used in any other context. I suppose we're applying these technologies, that proteomics and genomics and metabolomics, to try to, in our case, probe deep questions that still challenges in healthcare, in diseases and trying to intervene in those diseases. And I suppose Omics conjures the fact that we've probably got that puts us in a really good mood, that we think we can make progress in those areas.
What are the technologies that...
An associate professor at Harvard Medical School, and I study how your brain ages and how it ages badly in some conditions. When I was growing up, my amamma lived with us, and she had Alzheimer's research. Can I start again? Sorry. So my name is Judith Steen, and I am a professor at Harvard Medical School, and I study neurodegeneration. And as a child, I grew up with my amamma being in the house with Alzheimer's disease, and it affected me a lot. I saw her lose the person she was, and I saw how difficult it was for my mother as well to see her mother forget who she was. And over time, this stayed with me, and I decided that I would like to do something to study this disease and understand how we can keep our brains healthy as we age without forgetting who we are and without forgetting our family around us.
Okay. When you heard the name Omics for the first time,
Yes.
what were your thoughts and how did you relate to the event that we are having today?
When I first heard of Omics and the fact that there was art involved, I was excited because I have danced my whole life, and I dance for exercise. And I think it's a very good part of my life that keeps my brain healthy, because to remember all the steps and to use your body every day in exercise or every week is incredible. And I love music and I love art, and I asked my children to also participate. So
I'm the founder and chief scientific officer of a company called Intelligent Omics. Our company looks at the power of measurement of molecules within the human body and using the power of AI. And from that we can identify the key things that make a disease tick. And from that we can also identify diagnostics that help us detect disease earlier.
So this event that we are attending today, Omics, how do you relate to this, and what is the first thing that came to your mind when you heard the name?
So this is really an interesting event because it blends the thrill of science, but also it brings about culture. Many scientists have to have an artistic side as well. Sometimes in science we have to be really creative and have to really try and solve problems by thinking out of the box. And art, music, dance are all forms of creativity which can inspire us to be our muse in order to find new things about biology.
And so developed or evolved in the next 10 years? I mean, how can the world take this?
Yes. So I'm a computational biologist. That means a person who uses computers to model and understand biology. Now, with the technologies we have now, we're able to dig deeper and deeper into the mechanisms of biology at the molecular level. Since we sequenced the human genome, we can now understand so much more about diseases. And where I see this going, we're going to get more and more data, but more and more depth of information as well. So using approaches like machine learning and artificial intelligence, we can really dig into this data and understand what what the drivers are for a particular disease like cancer. Now from this, we can then potentially identify new drug targets. And that process won't take 10, 15 years as it has done previously. That process maybe will take 2 or 3 weeks. So we can rapidly get to new treatments that are effective and that are screened using the power of IT, the power of machine learning.
Fantastic. So, here's wishing you all the